Hey guys, I hope you're having a great day. Right now I'm going to go over lesson 5-3 in geometry, and I can't really do any of the problems from the homework, but I'm going to be going over some similar examples, and I think the best way to start is with the vocabulary. So the first thing that it introduces in the book is what the median of a triangle is. And it's actually quite simple, so let me show you. A median of a triangle goes from one vertex of the triangle, which is basically the pointy sides, like the points on the triangle, and it goes to the opposite side, which is kind of self-explanatory, and it intersects at the midpoint of the opposite side, which would make, if this point is, let's say, D, it would make AD congruent to DC simply because it bisects it at the midpoint. The next thing that it introduces is the centroid of a triangle. We didn't really use this much in class, but basically the centroid of the triangle is where each of the three medians intersect. So if we have this median, and then we have this median, they're going to roughly intersect here. Excuse my poor drawing abilities. And this point here is called the centroid. Now, when we're looking at the centroid, an interesting theorem pops up, which is basically what we're going to be using for the rest of the problems. And it states that the distance from the vertex to the centroid is 2/3 of the total distance, which leads us to believe that the distance from the centroid to the midpoint is 1/3 of the total distance. So let's call this point E. That would make let's make this x. That would make AX 2/3 the distance from AE, and it would make XE 1/3 the distance of AE. So let's go ahead and look at one of my poorly drawn examples again. And we're going to solve a problem. So if we look here, we have a few numbers. We know that this segment here is 3 units, and that this segment here is 10 units. So let's use those numbers to find some goals. The first thing I want to look at is we're going to try and find the distance of this segment right here. So in geometry, the first thing you always want to do is look at what we know. Well, we know that we have this centroid theorem here, and we know that this segment is 3 units. So if we know that the distance from the midpoint to the centroid is 1/3 the total distance, we know that this segment is going to be 2/3 of the total distance. So what we then have is 3 times 2, which is going to equal 6. So this segment is going to equal 6 units. And that's because if this is equal to 1/3 of the total distance, we're going to have 3 is equal to 1/3 of the total distance. We can then multiply each side by 3/1, because when you're going to divide, we have to multiply by the reciprocal, which is going to give us 9 equals the total distance. And then because this segment is 2/3 of the total distance, we have 2/3 of, which is the same as multiplication, the total distance, which is 9, which is going to give us 18/3, which is going to give us 6, I believe. Let's check that on a calculator because I'm terrible at mental math. 18 divided by 3 is equal to 6. So that's how we come across doing these problems where we have 2/3 the total distance. That's algebraically, you can probably put 2 and 2 together, that if this segment is 1/3 of the total distance and it's 3, and this is 2/3, that it's just going to kind of be 2 times. But if you're one of those people who needs to see it, that's how you do it algebraically. Now here we have another example, and I'll choose yellow. We have another example, and we're given this distance, which is from the vertex to the midpoint. So remember, because it's from the vertex to the midpoint, it's 2/3 the total distance. That's going to give us this distance. So we're going to go ahead and try and find that the length of that segment. So if this is 2/3 of the total distance, right, that's 10. So let's take a look. If 10 is equal to 2/3 the total distance, we can multiply this by 3/2 on both sides, and that's going to give us 30/2, which is going to equal 15 for this total distance. So if this part is 1/3 the total distance, we can take the total distance, 15, multiply it by 1/3. We can get 15 divided by 3, which equals 5. So we can tell that this segment is equal to 5 units. And again, you can probably see the pattern about how if this is 1/3, it's going to be half of the 2/3, or vice versa. And so that's how you do that type of problem. So we're going to look at one last example here. We have a fraction, which I know we all hate, but I'm going to do it anyway. So let's see if we can do this more quickly. We have this point, this centroid right here. So we know that this is 1/3 of the total distance, and then this is 2/3 of the total distance. So if this is 1/3 and that's 2/3, 2 1/3s is going to give you 2/3. So we can multiply this number by 2, and we'll get the length of this segment. So let's take a look. 35 multiplied by 2 is equal to 70. 70 plus 35 is 105. 105 divided by 3, that's going to come out to be 35. Now, let's try and find this segment. Well, this is 2/3 of the total distance, which is 12.5. So if we divide it by 2, that's going to give us 1/3 of the total distance. So that's equal to 6.25. So this segment is going to equal 6.25. I'm going to check my mental math here to make sure I didn't mislead you guys. 12.5 divided by 2 is indeed equal to 6.25, and 35 by 3 is equal to 105, and because we're trying to find 2/3, we'll just subtract the 35, and that gives us 70. So I hope this video helped you guys. If you have any suggestions or anything that I can do to improve these videos, or any, questions, be sure to let me know. You can Facebook message me, you can leave a comment on the video, you can check out my YouTube channel, send me a YouTube message. Any of those would be good. So go ahead and let me know how I did and anything I can do to improve. I hope this helped, and I hope you have a great day. Bye.